what's going on here. I told you yesterday where we're heading. We're heading another place to hide X, right? X will be hidden up in the exponent land. But we're going to talk about the tool of logs. And we did this weird part of the starter because here's what's weird. Every other thing we learn in math, we learn as a pair. We learn to add when we're little and subtract right afterwards, right? So we learn that 7 plus 9 equals 16. And we learn that those aren't exactly the same thing, but they're related to each other. They kind of undo each other because they're inverse operations. When we're little, we learn to multiply and we learn to divide at the same time, right? And that's why we don't have a trouble with the fact that you can write this as a multiplication problem. You can also write this as a division problem. Watch one other thing you can do. I can say 20 divided by 4. I can also say 20 times 1/4. And none of that strips you guys out because you've done it for so long, it feels like, yeah, multiply, divide, there's things, I understand them. And where you guys get a little weirded out is when we start talking about logs, because we did powering exponents like in 6th and 7th grade, and then we really wait like 4 years to undo it, and they don't seem connected. But they are totally connected. All that a log is going to do is it's going to rewrite this baby so I can get this guy out of the attic. We need him to be down low. And so we can power something to make it bigger, and we just don't use the word logging, but we can take the log of something. Now here's the other thing that's a bummer. When we multiply, we have a nice little symbol, divide, add, subtract, even raising to a power, we put it in a nice little cute place. You know what we do for logs? We just have the dumb word, right? So a lot of kids would be like, but what is a log? It's not an is, it's an action, right? It's taking the log, which is rewriting something. So the exponent, the power, is what we're solving for, right? That's all it is. It's just a way to rewrite. So if you turn your paper over, look at this. I got some notes. This is old school from Mrs. Tarantino Algebra 2 days. We're going to talk about this. So what is a logarithm? It's another way of writing exponents. So here's what I want you to write. It is inverse of it's the inverse of taking the power of something, of raising something to the power, is then we can undo it by taking the log, right? That's what it does. And it's the inverse. It undoes it, right? And that's what we need to know. So here's what I need you to be good at by the end of today. And you guys have seen this before, it's not new. I need you to be able to flip back and forth. Like I said, 4 plus 5 equals 9. 9 minus 5 equals 4. That you guys can do that in your sleep. That's nothing. We're going to be able to do that today with logs. So here's what we're going to start with. Little guy a to the x equals b. Here's an example of that. 3 squared equals 9, right? That's an example of, that's exponential form. It's got a little exponent, it's got a little base, it equals a number. We're going to call that an argument in a minute. Now, the way to unwrap it, to unwrite it, to kind of undo it, looks like this. And I literally say this in my head. I'm going to have the word log. The base, check this guy out. See how that's the base? The base goes in the basement. The exponent becomes our answer. And then finally, the last guy, the answer guy, we actually call, he has a name. His name is argument. And he is going the only place that's left. And what we're saying is the log A of B equals X. The base lives in the basement. The answer is the exponent. The leftover guy goes in the only leftover space. So what we're going to do tonight is we're going to flip back and forth between the two forms. Is that cool with everybody? Nice and easy. Super, super easy. So here we go. Let's start with taking this. Like last year when you guys saw this in Algebra 2 and Algebra 2 trig, you're like, what kind of weird stuff is this? So here's what you want to remember. The base lives in the basement. The answer is your exponent. This argument guy, he's your answer. Nice and easy. Nice and easy. Do me a favor. Write the next one out in exponential form. I certainly can. The base lives in the basement. The answer is the exponent. And then the random answer is there's just one space left. So here we go. The base is living in the basement. The exponent is our answer. Well, what is 14 squares? It's 196. Ooh, how about this next one? Can you rewrite this next one for me? With a square root somewhere in the answer? Could you do it with a square root? I sure can. So the next one, can you write it with a square root? Because guess what? When you have an answer that's an exponent, that exponent is 1/2. That's a square root, right? The base is in the basement. That's 1/2. That's my exponent. Hey, wait, she wants me to write it with a square root sign. And I know it's really tempting to do the last one in a weird way. Just think about it. The base lives in the basement. The answer is the exponent. You want to make sure it all makes sense. Yeah. Can you go the other way?
Go back. How does the 81 how does the 81 work?
Oh, so the base lived in the basement. The exponent was the answer, right? And whenever we have a fractional exponent, that's the same as a square root.
Wow.
Remember that little guy goes here, and that little guy goes there. How about these ones? Can you write it in logarithmic form? Right? Move some stuff around. Here's why it's easy. Write the word log. The base lives in the basement. The answer is your exponent. And then I got this random space, so I got to fill it with 64. Like, genuinely, I say it in my head when I do it. Base lives in the basement. The answer is the exponent. The base lives in the basement. The answer is the exponent. The base lives in the basement. The answer, don't make fun of me.
I'm just saying, this is going to be a lullaby for your grandkids.
I know. You mean little isosceles?
Your little
And Scalene? Yeah, she won't be very pretty. I always just gonna name my daughter Scalene and my son Isosceles. Yeah, but Isosceles seems like a kid who's handsome. Scalene seems like a girl who has to take her cousin to the prom. And she seems like she has a skin condition.
Yeah.
Like Scalene. The base lives in the basement. Answer. There we go. Okay. So you're like, why? Why do we do this? Here we go. Let's do some problems with it. Just need to do it. Here we go. Notice on these next 4 problems that are on your note sheet, the X is living in a different place on all of these. Ooh, he's right here. He's right here. He's right here. He's right here. Now, some of you are going to be able to eyeball this. Some of you are going to be able to look at it and think to yourself, 4 to the what gives you 16. And you're gonna be able to say, well, that would be 2. But some of you are gonna be like me and be much more comfortable writing it in exponential form. When I'm confused, I go back to what's familiar to me. 4 to the x equals 16. I know how to do that. I think to myself, 4 to the what will give me 16? Well, squared, so x is 2. Or I could even do this from last night. Ooh, look, the bases are the same. So easy. So the next one, you can either eyeball it and say 3 to the what gives you 27, or if you want to write it out, if that feels more comfortable to you, that's cool too, right? Totally fine with me. X would equal 3. Do me a favor, write the next one out for me, and if the answer will pop out at you. Okay, so we're just rewriting it. Look. So this is where it looks like, right? That's what we did last night. So either I can do it in my head, right? Because I know that 4 plus 4, when we said last night, you can get a common basis, right? I can turn 16 into 4 squared, right? And if the bases are the same, I did, but I actually knew that 3 times 2 times 3 is 27. So some of these are going to be easier to think of in your head, right? So watch this one. This is saying 7 to the second equals x. I can do that in my head. Right? 7 to the second, it's 49. Next one, watch what we're going to do. X to the second equals 25. So x equals 5. We're not going to worry about the negative one because we're just using the principles for our work. Okay, we're going to get a little dicier, but I love these ones. These are my favorites. And you're looking at that thinking, holy heck, is this hard? It's so not. Just rewrite it. Just rewrite it. The base is in the basement. The exponent goes there, equals x plus 5. Or sorry, x minus 5. Look how easy that is. You guys know how to do that. 3 to the first is 3. X minus 5. X equals 8. All you're doing is taking something that looks crazy and rewriting it. So can you do that on the next one for me with your neighbors? Just rewrite it. Nice and easy. It's not scary. Just rewrite it. So on this whole chapter, there are going to be times when I'm going to be a little confused. I'm like, oh, rewrite it. It makes me happy. I totally understand how to do it when I rewrite it. 6 to the second, 2x minus 4. 36 equals 2x minus 4. 40 equals 2x. X equals 20. You'll love these, because these are so clean. How about this next one? It's not on your paper, but I want you to try this one. Okay, try this one. Okay, you guys ready to try this one? Gotta go back in our heads a little bit. Here's what. Sometimes we leave numbers off. If I say x and I don't have an exponent, I say it's a 1. But it's not, things aren't always 1. So if I have a square root, it's not a 1 there, it's a 2. Scientists were the boss on this one. There's a hidden base there. And it's not a number that makes sense because it was scientists who said, we use this a lot in science, so we are requesting a specific number down there. Does anyone remember what it is? It's 10, because it's that stupid scientific notation. So when you don't see a base, that magical base is 10, right? Would 1 make more sense? Sure. Even 2 makes some kind of sense to me. 10, screw you, scientists. So we're going to say 10 to the second equals x plus 30. 100 equals x plus 30. X equals 70. Okay. The last little chunk, not on your paper, is something that looks scary, but is totally not. And I'm going to teach you a really cool shortcut for it. You guys ready? So I'm going to show you this problem. You can write this down on your arm, on your desk. You can find room somewhere on the little, like, there's this little thing like evaluating. You can do it down here. You can write them down there, right? Here's what. We're going to look at this guy. And I'm going to rewrite him as an exponent. And then I'm going to show you a really cool shortcut. So I'm going to say 4, that's my base, to the x equals 4 to the 57. So take a look at that. What is x? And it should be a really easy answer for you. It is 57. Here's what's cool. I don't always want to write that every time because I'm lazy. And the cool rule is this. If your base and your big number, your argument, match, I'm going to be really careful here because Mrs. Dill will kill me for saying this. They don't actually cancel out, but they act like they cancel out. They go away. It just works like that. Happens every time. But I don't want you to ever go to calculator and be like, you just cancel them. Not really, but they kind of do get canceled. So looking at this one, super easy. Guess what? I got a base and an argument the same. It's like they cancel. So look what it is. 15 is x. It's like they cancel right here. They go away. 3x plus 5 equals negative 10. I move that goofy 5 over. 3x equals negative 15. X equals negative 5. It's a nice trick. It's a nice trick that makes your life a little bit like, oh, they just go away. With that in mind, there's one other trick that works. Works when he's the big number, and it works when he's the little number. Guess what happens? Raising a log to itself, it's like they cancel out. It's just 9. Log root 2, same thing. That actually is going to be, it's going to become 1. So just 1 times 8. This just becomes 1, and you're good to go. Yeah, just watch for those. Just watch for those. Okay, I'm done. Here's what. Your homework looks scary, and it will take you literally 7 minutes because these problems are so, are so easy. So we're going to do these. We're going to knock them out, and then tomorrow we do a lot of properties, also easy. So you guys got this. Good job, everybody.